Let's start the video by discussing some important limitations of mean deviation. In a series where the degree of variability is very high, the median is not a representative central tendency. Thus, the mean deviation about median calculated for such series cannot be fully relied. Also, in many cases, it may lead to bad results, as the sum of deviations from the mean is more than the sum of deviations from the median. Now, let us discuss another important concept, that is variance and standard deviation, which is an important aspect of statistics. Let x1, x2, x3 up to xn be n observations and x bar be their mean, then x1 minus x bar the whole square plus x2 minus x bar the whole square plus and so on up to xn minus x bar the whole square is equal to summation I equal to 1 to n xi minus x bar the whole square. If this sum is 0, then each xi minus x bar has to be 0. This implies that there is no dispersion at all, as all the observations are equal to the mean, that is x bar. Now, if the sum is very small, this indicates that observations x1, x2 up to xn are close to the mean x bar, and therefore there is a lower degree of dispersion. And on the contrary, if the sum is large, there is a higher degree of dispersion of the observations from the mean. Alright. Now, what is variance? It is the mean of the square of the deviations from mean and is denoted by sigma square. Therefore, the variance of n observations x1, x2 up to xn is given by sigma square is equal to 1 by n summation I equal to 1 to n xi minus x bar the whole square, where n is nothing but the summation I equal to 1 to n fi and x bar is a mean. Let us solve a question. Find the variance of the following data 6, 8, 10, 12, 13, 16, 18, 20, 22, 23. Let's see the solution. The mean is calculated by step deviation method taking 14 as the assumed mean. Now, what is the number of observation here? Here we have 10 observations. So, n is equal to 10. Now, for each xi value, find di, which is obtained by xi minus assumed mean by 2. Now, after getting each di, we go for finding the mean. And the mean is nothing but assumed mean plus summation I equal to 1 to n di by n into h, which is equal to 14 plus 5 by 10 into 2, which is equal to 15. Now, let us find the deviations from mean. Now, we have to take the square of these deviations. See the table. For value xi is equal to 6. The deviation is equal to 6 minus 15. We get it as minus 9. Now, the square of minus 9, that is, we get it as 81. Likewise, we can calculate the remaining values. Now, we have to find the variance using the standard equation. Substituting the value here, we get it as 1 by 10 into 330, which is equal to 33. Now, the standard deviation is obtained by taking the square root of 33, which is equal to 5.74. Now, let us find the variance of first 50 natural numbers. Let's see the solution. The mean of first 50 even natural numbers is given by 1 by 50 into 2 plus 4 plus up to 100, which is equal to 1 by 50 into 50 by 2 into 102, which is equal to 51. Now, what is the variance? Variance is nothing but 1 by 50 into 2 square plus 4 square plus up to 100 square minus 51 square, which is equal to taking 4 outside, 4 by 50 into 1 square plus 2 square up to 50 square minus 51 square. Cancelling, we get it as 2 by 25 into 50 into 51 into 101 by 6 minus 51 square. And on solving, we get it as 17 into 202 minus 153, and we get the final answer as 833 as the variance. Now, let us discuss standard deviation. What is actually standard deviation? The proper measure of dispersion about the mean of a set of observation is expressed as the positive square root of the variance, and that is called the standard deviation, and is usually denoted by sigma, and the equation is square root of 1 by n summation I equal to 1 to n xi minus x bar the whole square. Let us discuss the standard deviation of a discrete frequency distribution. Let's have a look into this table. The table shows the discrete frequency distribution. For each xi, we have each frequency. Alright, here in this case, the standard deviation is given by square root of 1 by n summation I equal to 1 to n fi into xi minus x bar the whole square, where n is the sum of frequencies, that is summation I equal to 1 to n fi. Now, next we will discuss about the standard deviation of a continuous frequency distribution. If there is a frequency distribution of n classes, each class is defined by its midpoint xi along with their frequency fi. Then the standard deviation will be obtained by the formula sigma is equal to square root of 1 by n into I equal to 1 to n. Sigma is equal to square root of 1 by n into summation I equal to 1 to n fi into xi minus x bar the whole square, where x bar is nothing but the mean of the distribution and n is the sum of frequencies. Let's do one problem to get a better understanding. Calculate the mean, variance and standard deviation for the given distribution in the table. This is a table. Let us solve this question by presenting the data in tabular form. We have 4 columns, one for the class interval and the other for fi values, then xi values, and the last column is to find the product of, that is fi into xi. Now, for each fi and xi, we need to find fi into xi. And already I have calculated the values and found out the values. And the sum of all fi xi, we get it as 3100. So we have mean x bar is equal to 1 by n summation I equal to 1 to 7 fi into xi. Substituting the value here, we get 3100 divided by 50, and it is equal to 62. Now we have to find 2 more parameters in order to find variance. That is, one is for finding the xi minus x bar the whole square, and one for finding fi into xi minus x bar the whole square as shown in the table. Now we have got enough data to find the variance. Alright. Now the variance is given by 1 by n summation I equal to 1 to 7, as we have 7 values, fi into xi minus x bar the whole square, which is equal to 1 by 50 into 10,050, and we get it as 201 as the variance. And the standard deviation is just the square root of 201, and we get the value as 14.18. Now it's a question time. If the variance of 20 observations is 5 and each observation is multiplied by 2, then find the new variance. The answer to this question can be solved using the concept which we have discussed here. Now, let's do a quick recap.
Manorama Horizon. Learning made simple.